Ever get the feeling that some words have, like a built-in ranking system?
I think I know what you mean.
Like furious isn't just more than annoyed.
Right.
It feels miles farther away.
Yeah.
Even though they're both on the anger spectrum.
It's fascinating, isn't it, how we intuitively grasp those degrees of intensity in language.
Totally. And that's exactly what today's deep dive is all about. We're diving into some brand new research that explores how our brains handle these graded words.
Words that exist on a scale, yeah.
Words that exist on a scale. Plus, we'll even touch on why this seemingly simple thing throws AI for a loop.
It's true. AI really struggles with this.
Huge shout out right off the bat to the team behind this research. Sashank Varma and Vijay Marupudi from Georgia Tech.
Oh, I know their work.
Emily Sanford at UC Berkeley. Olivia Shaffer at the University of Louisville.
Wow, what a team.
Andy R. Brookley at McAllister College. Talk about a brain trust.
Definitely a brain trust.
So where do we even begin with unpacking this idea of graded words?
Well, think about words like tiny, small, big, huge for size, or those emotion words you mentioned. Calm, annoyed, angry, furious for anger. They're not just categories, there's a spectrum.
Like a sliding scale of intensity?
Exactly. And what these researchers suspect is fascinating. They think our brains might use a similar process to understand these graded words as we do with numbers.
So instead of just memorizing a definition, our brains are putting huge, way down a mental number line compared to tiny.
Yeah, that's the idea.
That's wild. But how do you even begin to test something like that?
These researchers designed some really clever experiments. One of them involved showing people pairs of words, say none and all, and asking them to pick the word that represents more of something.
Okay, so far so good. But how does that show our brains are treating words like numbers?
Well, they found something called the distance effect. People were much faster to choose between none and all than they were with words closer together on the scale, like some and most.
Because none and all feel farther apart in our minds, just like on a number line.
You got it.
Wow.
And to make sure this wasn't just a fluke, they ran the same experiment with actual number pairs.
Ooh, clever.
And guess what? Same pattern. People were quicker with numbers spaced farther apart. It really suggests our brains might be using a similar mental ruler for both.
So cool. Okay, this is blowing my mind.
It's wild, isn't it?
Our brains are playing number games with words without us even knowing it. But how can we be sure this distance effect isn't just some quirk of language itself?
Right.
Maybe none and all just naturally sound more different than some and most.
That's a great question. And the researchers had the same thought. They wanted to see the actual layout of these words in our brains, not just how quickly we react to them.
So how do you peek inside someone's mind and map out their word associations? It's not like we can just crack open a skull and...
Well, not literally, of course,
Yeah.
but they used a clever technique to create a visual map of how our brains organize these words.
like a mind map kind of thing.
Kind of.
Right.
They asked people to rate the similarity of different word pairs and used those ratings to create these maps.
So instead of a confusing brain scan, we get a cool word map.
Exactly.
I like where this is going. So what did these maps reveal?
Well, it turns out the graded words were arranged on a line.
Just like we suspected with the distance effect.
Yeah, but visually.
Whoa.
It showed that our brains weren't just processing them faster, they were literally placing them farther apart in a mental space.
Double the evidence.
Yeah.
So it's not just reaction times. It's how similar or different our brains perceive these words to be.
Yeah.
That's a pretty solid case for the whole mental number line idea.
Right. It's pretty compelling. And remember that ratio effect we talked about earlier, how comparisons are faster with bigger differences?
Yeah, I remember.
Well, that showed up on the maps too.
Wait, really? How so?
The distance between good and great on the map was smaller than the distance between fair and good. It's like the scale gets compressed as you move towards the extremes, mirroring what we saw with the reaction times.
So our brains not only space out those extreme words like none and all, but they also squish together words at either end of the scale.
It seems that way.
It's like our brains have their own internal ruler markings.
Right.
This is getting pretty convincing. But there's still one nagging question. What if our brains are just picking up on how these words are statistically used in language?
That's a good point.
Like we do tend to use none and all in more like contrasting situations than we do some and most.
True.
So maybe our brains are simply reflecting those language patterns.
It's possible.
Like we're just super sophisticated parrots mimicking what we've heard.
And to test that very idea, the researchers turned to the world of artificial intelligence.
Oh, here we go.
They wondered if AI, with its ability to process mountains of text data, would also show these distance and ratio effects.
Makes sense.
If so, maybe our brains aren't so special after all.
So they decided to throw a bunch of graded words at an AI and see what happens. This is getting exciting.
Basically.
Did the AI crack the code?
Well, they threw the kitchen sink at it, really.
Like, what kind of AI are we talking about here?
We're talking about some of the most sophisticated language models out there.
Oh, wow.
LSA, Word2Vec, Love,
Okay.
BERT, Roberta, GPT-2.
The heavy hitters?
The heavy hitters of the AI world.
Okay, I'm on the edge of my seat. Spill the tea. Did any of them pass the test?
Here's the big reveal. None of them could fully replicate what human brains do so effortlessly.
Wait, really?
Yeah.
So even with all that data crunching power, AI couldn't quite grasp the subtle nuances of furious versus just a little annoyed.
Exactly. Some models got close, showing the distance effect or the ratio effect, but none of them could consistently match human performance across the board.
Fascinating.
This suggests that our brains are doing something more than just passively soaking up language patterns.
So what's the secret sauce our brains have that AI is missing? What's going on under the hood?
Well, the researchers believe that something called magnitude representations might be the key.
Magnitude representations. Sounds intense.
It is pretty complex.
What in the world is that?
Yeah.
Magnitude representation. Sounds intense. What in the world is that?
It's the brain's way of representing quantities.
Quantities.
Like size, number, or even intensity
Okay.
on a kind of mental continuum. It's how we can instantly tell that, say, a whale is bigger than a goldfish.
Right.
Or that furious is a more extreme emotion than annoyed.
So instead of just matching words to dictionary definitions, our brains are adding this extra layer of how much to the meaning.
Precisely. And this research suggests that this ability might be crucial for how we understand and use graded words. It's a fundamental building block of our language system.
So while AI might be able to crunch through terabytes of text and spit out grammatically perfect sentences, it's missing that innate sense of quantity and intensity that makes human language so nuanced.
It seems that way.
Yeah.
And for AI developers, this research isn't a dead end. It's a challenge. It highlights a key area where AI needs to catch up if we want it to truly understand and use language like humans do.
It makes you wonder, how would you even begin to program a computer to feel the difference between tiny and huge? Or to grasp that furious is miles farther down the anger line than annoyed?
Yeah, it's a tough one.
It's like trying to teach a robot to understand a gut feeling.
It's a fascinating puzzle, isn't it? And this research provides some important clues. If we can figure out how to build AI that incorporates this innate sense of magnitude, who knows what we might be able to achieve.
This whole deep dive has been one aha moment after another. We started with a simple question about how we understand words on a scale, and now it feels like we've stumbled onto one of the key ingredients of human cognition.
It's pretty amazing, isn't it?
It makes you appreciate the quiet power of the brain.
It really does. And the best part is we're only just scratching the surface. There's so much more to explore in this fascinating intersection of language, psychology, and artificial intelligence.
A huge thank you to Sashank Varma, Vijay Marupudi, Emily Sanford, Olivia Shaffer, and Brooke for taking us on this incredible journey. And to you, dear listener, the next time you find yourself reaching for a graded word, take a moment to appreciate the subtle but powerful mental gymnastics happening behind the scenes. Your brain, my friend, is a marvel. This has been The Deep Dive. Catch you next time as we plunge into another fascinating corner of the knowledge universe.